Okay, so we're back with part 2 of the Labor Day E-Day lecture. So we're going to start it on 1.7 now, and there's a warm-up problem here, which I'd like you all to pause the video now and complete this warm-up problem, and then once you think you have an answer for both of these questions, then we can go through them together. So go ahead and pause and try those out. Once you're done pausing, let's get right into them. Okay, so Millicent is a cat hoarder and she currently has 100 cats in her basement and plans to increase the size of her clouder by 3% each year. Okay, so this is telling us that P naught is going to be 100, and this is telling us that R is 0.03, which means that A is going to be equal to 1.03. Okay, that's our initial information. So the federal government will evict her if she passes 150 cats. So how many years can Millicent operate on the fringes of society before being evicted? Wow, this is a crazy problem. All right. Well, what we're asked here is what value t causes P of t to be equal to 150. That's what they're asking. What time am I going to pass 150 cats? Okay, so first of all, let's create our equation. We know that P of t should be equal to P naught, that's 100, times A, that's 1.03, to the power t. Now, instead of telling us the time and asking us to figure out the cats, they're giving us the number of cats and asking us to figure out the time. Okay, so what we're going to do is just set this right-hand side equal to 150. So we'll have 150 equal to 100 times 1.03 to the power t. Divide both sides by 100. Now my unknown is in the exponent, so that's telling me that I should apply the natural logarithm. (1.03 to the power t). Based on my logarithm rules, I know I can bring the t down front and write this as t times ln of 1.03. So now I just need to divide both sides by ln of 1.03 to get my answer. So I'll write that up here. T is going to be equal to ln of 1.5 divided by ln of 1.03. And if I type that into my calculator, I'll get something like t equals 13.7 ... years. Okay, it's not exactly a round number. Okay, so that's how we do one of these problems where they ask us for the exponent instead of for P of t. Okay, so let's move on to part B. Part B asks us if she doesn't get caught, how long until her clouder doubles in size? Okay, so the way that we're going to solve this one is going to be similar, except instead of telling us what P of t is, they tell us that her clouder should double in size. Well, if my original clouder is 100 cats, then double that is 200 cats. So we need to come up with a formula such that 200 is equal to 100 times 1.03 to the power t. And we can solve this just like before. We'll divide both sides. We get 2 equals 1.03 to the power t. We'll take the natural log of both sides. T times ln of 1.03. Then we'll divide both sides. This will tell us that t is equal to ln of 2 divided by ln of 1.03. And if we cared over much, we could type that into our calculator and get a result. I'll leave that up to you guys. So that is those two warm-up problems. We're going to move on to some definitions now. Kind of talked about this a little bit in the last video, but let's have some actual definitions for annual versus continuous interest. So my annual interest rate is the number R such that, that's what ST means, such that P of T is equal to P naught times 1 plus R to the power T. Okay? Continuous interest rate, on the other hand, is the number K such that P of T equals P naught e to the KT. Okay, so this goes back to those two different forms of exponential functions where we can have e as the base or we can have a as the base. Okay, so that's the difference between annual interest rates and continuous interest rates. So let's jump in and apply these definitions. Problem 1 asks us, suppose $6,000 is deposited into an account, paying interest at a nominal rate of 2.7%. Should really just say 2.7%. Find the balance after 5 years if the interest is compounded annually versus compounded continuously. Okay. So what I want to point out here is if we say nominal rate, what we mean is in name only. So when we write nominal, we mean that the bank has told us your interest rate will be 2.7%, but they haven't specified whether they mean 2.7% monthly, 2.7% annually, 2.7% continuously. That's what is being specified down here in the problem. So part A, they say, okay, the nominal interest rate is applied annually. Part B, they tell us that the nominal interest rate is applied continuously. Okay, so let's start off by getting our values here. We know that we should have P of T equals P naught times A to the power T for annual interest. And they gave us 2.7%, that's going to be our R. So A is going to be 1 plus that, you get 1.027. Okay, P naught is going to be 6,000. It's our initial deposit. And we want to find the balance 5 years after we deposit the money. So let's write P of T in more detail. P of T is going to be equal to 6,000 times 1.027 to the power T, which means that P of 5 will be that stuff to the 5th power. So if we plug that in, we'll get 6,854.9. So that's how much money we'll have left at the end. So we made like 850 bucks of interest. Okay, now let's try doing it continuously. Okay, in this case, we're not going to convert from our annual equation because we're simply going to take the nominal interest rate and set that as equal to R in the annual case, and in the continuous case, we're just going to set that equal to K. So for this one, we're going to have P of T equal to 6,000 times e to the 0.027 t. Okay, now when we plug in P of 5, we'll do 6,000 times e to the 0.027 times t. There should be a 5 in there. Let me put a 5 in there. And we would just multiply that out in the exponent, and then we'd do e to that power, multiply by 6,000, and we'd get 6,867.22. So we did a little bit better using continuous interest than we did with annual interest. Okay. Move on to problem number 2 now. Jordan's parents would like to invest some money to help pay his future college tuition. Their bank will pay an interest on their investment at a nominal rate of 4%. If interest is compounded annually, how much should Jordan's parents invest in order for the account to have $24,000 in 8 years? Okay, I want to point out a key difference. A key difference in this problem than in other problems. We have not been given our initial deposit. We've been given the ending balance. So what we've been given is P of 18 is going to be equal to 24,000. And our job is to find P naught. So first of all, let's set up our equation. We know that P of t should be equal to P naught, which we don't know, times A. A is going to be 1 plus R, so 1.04 to the power t. So this is our equation. And usually we know this yellow piece and we want to find P of t. In this case, they're going to give us P of t and they want us to find out what is P naught. So let's go ahead and plug in. We know that P of 18 is 24,000. Remember, the 18 on the inside of the parentheses means that t takes that value. So this is going to be equal to P naught times 1.04 to the power 18. So if I want to find P naught, I'm just going to divide both sides by that number which it's being multiplied by. So this tells me P naught equals 24,000 divided by 1.04 to the power 18, which is equal to somewhere around 11,847-ish. Okay, now let's try part B. Same goal, different equation. P of 18 is still equal to 24,000. We know P of t is going to be equal to P naught. Now what's going to go in here is going to be e to the power k, where k is given to me by the nominal interest rate. So I'll write e to the 0.04t. Okay, now same deal. P of 18 equals 24,000 equals P naught times e to the 0.04 times 18. So if I multiply that out, then I can just divide both sides, wind up with P naught equals 24,000 divided by e to the 0.04 times 18. With the help of a calculator, I can figure out that's going to be $11,682-ish. By ish, I mean there are some decimals which are too long to possibly write out. Okay, so we found out that our initial investment should be smaller if we're compounding interest continuously. which means that if we don't have to put as much money in the bank to achieve the same result, that's the path that I should probably take, since it's going to cost me less money to get the result that I want. Okay, do problem 3 now. Suppose an investment decreases by a total of 30% over a period of 10 years. At what annual percent rate is it decreasing? Okay, so first of all, we know that P of t is equal to P naught times A to the power t. Okay, we're using this equation here. And we're supposed to figure out what is R, where R is equal to, A is equal to 1 plus R, so R is equal to A minus 1. Okay, so this is what we want to keep in mind up here. And they tell us we can figure this out without even knowing the initial value. It's true. That's a fact. What they've told us is that P of T1 is equal to P naught times A to the power T1. We would plug in T1. We know that P of T2, later on, that's equal to P naught times A to the power T2. So we have these two equations in combination with the fact that P of T2 equals 0.7 times P of T1. Okay? Since we decreased by 30%, that means the amount that we have left over after 10 years is going to be 70% of what we started with. So using these three equations, which I'll put a pink thing around them, using these three equations, we can actually figure out what A is going to be. If we know what A is, we know what R is. So the way I'm going to do it is as follows. I'm going to write P naught A to the T2 equals 0.7, and now in here I'm going to put P of T1, so that's going to be P naught times A to the power T1. Okay, so now what I'm going to do is I'm going to divide both sides by P naught A to the power T1. I can just go ahead and cancel these two terms since they appear on both sides. And when I divide both sides by A to the T1, divide by A to the T1, we get 0.7 equals A to the T2 divided by A to the T1, which is equal to A to the T2 minus T1. And I say, aha, aha. T2 minus T1 is the difference in time between T2 and T1. I know that from the problem. It's 10 years. So this is equal to A to the power 10. So solving this entire equation, I have 0.7 equals A to the power 10. I'll take everything to the 1/10th power and get A equals 0.7 to the 1/10th power. And that tells me that A is equal to, where is it? 0.96496 ... which tells me that R is going to be 1 minus, this minus 1, so we get negative 0.035038 ... That's going to be our R. Okay, that's it for this part of the video.